Hello, my name is Kostas Papaspiropoulos. I work as a postdoctoral researcher in the Laboratory of Forest Economics in Aristotle University of Thessaloniki in Greece, and together with my professor Dimitrios Karamanolis, we present here in the International Academic Forum conference in Brighton for 2015 the work identifying material and energy cost categories of forest products production using material flow cost accounting. We have presented last year material flow cost accounting for forestry sector, and we evolve in this issue this year. And material flow cost accounting is a methodology arising from the industry sector. It helps environmental managers to track inefficiencies in the production process. It promotes the better allocation of wastes to the responsible products or non-products. And it offers cost savings and less environmental burdens. Lately, the method has been standardized with the International Standard Organization Certificate 14051, and it has been applied a lot in the Japan industry. According to researchers, its application is quite limited compared to the potential application of the method, and there are rare applications in other sectors than industry. Primary sector is a very interesting sector for using such methodology because agriculture and forestry especially are energy intensive sectors. Managers in this area are usually not aware of waste and cost savings methods, as is material flow cost accounting method. And it is an interesting area for applying material flow cost accounting. Forestry usually works with long-term planning, and this is a very interesting issue in this sector. The rotation period is usually some decades in forest ecosystems, so we have to be very careful with decisions that we make. The first harvest is usually more than 5 years in forest plantations, and in the forest stands this may be more than 20 years. So our decisions today can affect next generations, and such investments pose significant risks which have to be taken into account. The products that are produced in the forest sector mainly are timber and its industrial products, and non-timber forest products were relevant in the last years, with query species that are used for hunting, fruits, honey, and Christmas trees, some of the examples of the non-timber forest products. And of course there are services very important for our lives. Forest sector produces the carbon sequestration, which is very relevant in the climate change scientific discipline in the last years. The land protection, protection from erosion and floods, and the environmental law enforcement, an issue which we presented last year in the same conference. So material flow cost accounting and forestry have not been combined many times in the literature, and researchers generally criticize that most of material flow cost accounting applications are past-oriented, routinely generated, and short-term, so there are calls for long-term future-oriented approaches such as eco-efficient financial planning and eco-efficient investment appraisal. So we think that such estimations are needed in forestry, as we explained earlier. So the objective of our research was to research on material flow cost accounting and its potential use to the main forest products such as timber or cultivated Christmas trees. identify the main material and energy costs in this area, give examples of the differences between material flow cost accounting and its conventional counterpart, and demonstrate the benefit for reduced material and energy resources and the protection of natural environment. So how we worked on this research? We focused on the following issues. We looked at the literature and we tried to find the recent advances in material flow cost accounting theory. We looked at the forest products production process, and we made comparisons with conventional accounting through two scenarios that we will present later. So how do we apply material flow cost accounting? As we said earlier, ISO 14051 has standardized the method and defines MFCA as a tool for quantifying the flows and stocks of materials in processes or production lines in both physical and monetary units. And it's applicable to any organization that uses materials energy regardless of their products or services. And this line was what made us to think to use material flow cost accounting in our research. And material flow cost accounting is included in the general environmental management accounting framework, which is very relevant in the environmental management sector the last years. So how we perform the MFCA methodology, some steps for performing it. We have to construct the flow structure modeling first, which is the determination of the system boundaries. To what extent should we account for the inputs and the products that are produced from our production process, and the time period of the assessment for the modeling. Then we have to quantify the flows or the materials that were used as inputs in the production process, or the outputs, the desirable outputs that are produced, and the non-product outputs, which are the waste, these outputs that we don't want but become a result of our production process. And then we have to do the cost appraisal, which is we have to account for the costs of the materials that we used, the energy costs that we used, the waste management costs, and the system costs. We explain these four cost categories in this slide. Material costs are the cost of raw and auxiliary materials for the production process. They are the only direct costs of the methodology. This means that they can be allocated straightly to the products that are responsible for these costs. The energy costs are the energy entered in the production process, and usually the energy costs are not straightly directly allocated to the responsible products, so we have to find some indicators to do the work. There are waste management costs. These are the costs for handling waste and emissions, and there are the system costs, which represent labor costs and depreciation. We believe that system costs are already relevant to the sector and managers know how to treat them. The waste management costs are not yet internalized by organizations, since legislation doesn't really push organizations to find ways to manage their costs, especially in Greece, where we took our research. So we work with material and energy costs in the next slides. Applying material flow cost accounting. Material flow cost accounting has been mainly applied in a past-oriented, routinely generated short-term framework, as we explained before. It may reveal inefficiencies from last accounting period and force improvements in the next accounting period if we take this approach. But long-term and future-oriented MFCA approaches may be used and may be more interesting, since net present value of future material and energy losses and costs may offer a more holistic approach in the issue. So which are the main material and energy costs in forestry? The material costs are the water that is used, the fertilizer in some plantations, the feed in some public farms for species rearing, wood, seedlings and seeds, and the energy are usually oil, gas, and electricity. So we use two scenarios, as we said. The first scenario is a plantation, production of Christmas trees. And the second scenario is the production of timber, which is usually performed by the Public Forest Service. So here we have a comparison with conventional cost accounting. So we see first the inputs that they are used for production of Christmas trees. So we may say that we use 100 kilos of materials, which cost 1,000 euros, and we have energy that costs 100 euros. So the total cost of materials and energy are 1,100 euros. And usually conventional cost accounting allocates these costs straightly to product outputs, which may be, in our case, 75 kilos. Let's count the Christmas trees in kilos and not in trees produced. So in conventional cost accounting, we have all material and energy costs allocated to product outputs, and not a single euro in the non-product outputs, which, as we can see, it is 25 kilos. And material flow cost accounting, what is the important thing here, allocates this cost, which is almost 275 euros in the non-product output. So the manager can see here that there is potential for cost saving by reducing the material cost or the energy cost. Some similar issues in the production of timber. Usually there are no materials in this production process. We have the energy for the machinery that the timber loggers use, and the transportation of the loggers to the forest stand, which they use for the production of timber. So we have 600 euros, for example, for the energy here. In the conventional cost accounting method, all this cost is allocated to the product outputs, but in material flow cost accounting, the transportation energy especially is not a manufactured product output, but it's totally a non-product output, and it should be allocated to the non-product outputs. So we should find an indicator for the energy for the machinery to allocate it to the product output. But as you can see, most of the inputs are becoming non-product outputs, and managers here can find the potential for reducing this cost. So a past-oriented short-term MFCA approach could be used to test the previous significant non-product outputs. This could be a first approach to MFCA in forestry, but we believe that MFCA could improve long-term cost-benefit analysis of forestry investments, especially in forest stands where we have high rotation periods. And the future-oriented MFCA approach could project the future material losses and energy costs of the current technology used and compare it with alternative technology. So future plans could be altered for cost savings improvement, and of course for reducing the environmental burden produced by the use of energy and material that are not becoming product outputs. So we conclude here. We believe that it seems rational to apply MFCA in the primary sector and especially in forestry, which is relevant for future-oriented and long-term implementation. We have shown that there are material and energy losses in forestry production process, and a case study with real data is required to test if what we have shown here is really produced with a real case study. Cost-benefit analysis could be improved with material flow cost accounting, and a significant improvement in co-efficiency in the sector is expected. I would like to thank the State Scholarships Foundation, IKI, in Greece, for the Fellowships of Excellence for Postgraduate Studies in Greece, Zima's Problem, for funding me for this research. I would like to thank you for being here and watching my presentation. Thank you very much.